The goal of section 7.5 is really to take your concept of being able to integrate a function and taking it a little bit step further in the sense of we're going to be introducing some functions that we don't exactly have nice and fancy rules for. Like, for example, when we want to take the integral of x squared right there, we just knew all we had to do was raise the power by 1 and divide by that new power. We had a rule for it. Well, what if we're looking at something that just doesn't look exactly what we have something special for? Like back in the world of derivatives, remember if I had you take the derivative of sine x, you're like, oh, we had a rule. It was just cosine x. Now, but what if I changed it from just sine x to write it as a sine squared x? So by adding that exponent, what we had to do was a chain rule. We had to identify we had to break it down using substitution. We wrote it as 2 sine x, and then we had to multiply by the derivative of that base, and it was cosine x. So by just adding that squared in there, it kind of really changed up the whole function. Well, we have the exact same process happening with integrals. Is what if you're asked to take an integral of, it's nothing that we have a fancy, formula for, nothing that's recognizable. And so what you want to do is just basically what we did with derivatives. And here's your steps. The first thing you want to do is recognize, okay, within what's given to you that you're asked to integrate, can you identify a main function? And then can you also see its derivative? Okay, and then you're going to replace the main function with u and replace the derivative portion with du. Okay, so with all within one integral, one problem, you should be able to see, okay, I can recognize a portion that I can put u in, and then I can also recognize its derivative, and that's the key. Then you're going to integrate it as usual and then go back and substitute back in, hence the substitution rule. Okay, so here for example 1, we're going to start out with just something basic. They're actually going to help you. They're going to tell you what u is. They say, okay, over here where we're asked to take the integral of, we're going to let u be 7x minus 1. Well, the next thing I want to do is find du. So the derivative of u with respect to x is 7, or we can write then du as 7 dx. Okay, so going back to our main equation, then the 7 dx part is going to be du, and the 7x minus 1 is what's going to be u. So this is really asking us for the integral of the square root of u du, or the integral of u to the 1/2 du, and that's just basically something simple. We have a rule for that. So it's going to be, you take your base, add 1 to that power, and divide by the new power. And then if we want to, we can put of course, the plus c. And then just cleaning it up, because since you're dividing by a fraction, let's write this instead as 2/3 u to the 3/2 plus c. And then to wrap this up, to actually consider our full answer, we just have to go back in and replace what u was. So the overall answer to this whole problem is then going to be 2/3 7x minus 1 to the 3/2 plus c. And that's how we go about integrating. So let's go over here to part B. Again, they're helping you out. We know that u is 3x squared plus 4x. So we want to go in and identify du dx, which is 6x plus 4, or that du is 6x plus 4 dx. So let's go to the main problem and see if we can recognize the two portions of it. Well, there's obviously u right here, raised to the 4th power, and then the 3x plus 2 dx, there's du. So this is the integral of u to the 4th du, which is going to be u to the 5th over 5 plus c. Or if you want to write it as, we can write it as 1/5 u to the 5th plus c. And then to write it all as one big answer putting our u back in, it's just going to be 1/5 3x squared plus 4x, all of that to the 5th power plus c. And there is our answer for that one. Okay, so practicing a little bit further, let's get into some trigonometric functions. They identify for you that u is going to be 1 minus cosine of t over 2. And notice over here, that's the part that has the power to it. And then let's find du. Well, obviously the other variable is t, so we're going to find du dt. So the derivative of u obviously is going to be negative. And the derivative of cosine of any angle is the sine of any angle. And technically, it's going to be the negative sine of that angle. So together then, du is going to be negative, negative, positive. sine of t over 2 dt. Okay, so there's du right there, and that's what we're going to substitute it with right there. Okay, so let's go into our problem. Our u is being squared, so we're going to take the integral of u squared du. So that's going to be u cubed over 3 plus c, or 1/3. Our u is 1 minus cosine t over 2, and then plus c with a squared, or I'm sorry, a cube on the outside. And there's our answer for that one. Okay. And going on, right, looking here at example D, just keep on doing what we've been doing. We know that u is going to be x to 3/2 minus 1, so right here, x to 3/2 minus 1, and then du, oops, on a little lag there in my stylus, then du is going to be 3/2 x to the 1/2 dx. Okay, so if we recognize, try to see what's present here, du is the same thing as saying 3/2 x to the 1/2 would be the square root of x dx. So it looks like I've got the square root of the x, I've got dx, all I need is 3/2. So if I wrote this problem instead as 3/2 square root of x times sine squared of x to the 3/2 minus 1 dx, obviously since I added a 3/2 to the front, I've got to counterbalance it with a 2/3 out front. Okay, so now present, I've got 2/3 times the integral. The 3/2 x and dx is all going to be my du, and I just have sine squared u du. Okay, well now if this was sine to the first, we're good to go. We already have a formula to how to take the integral of sine to the first, but how do we take the integral of sine squared? We don't have a formula for that. Let's always go back and see about our world of trig substitutions. In the world of trig, we can replace sine squared u with 1 minus cosine of 2u over 2. So if we go in and make that substitution, notice we're going to be replacing a sine squared with a cosine to the first, and that is definitely something that we know and can work with. So this will be 2/3 times the integral of 1 minus cosine of 2u over 2 du. Okay. So let's go ahead and just kind of cancel those 2's across there and make our lives a little bit easier. So that just leaves a 1/3 out front, and we're taking the integral of 1 minus cosine of 2u and then du. Okay, so finishing this up, 1/3. The integral of 1 with respect to du would be just u. The integral of negative cosine, or just the integral of cosine, is sine of the same angle, so sine of 2u. And looking more closely, if you kind of stare at the formula a little bit more, because we finally have a number in front of our angle, we actually have to put the counterbalance of it out front. So we have to always, it was like 1 over k out front, we got to go with that. So minus the 1/2 sine of 2u, and then as always, plus c. Okay, so it looks like I am going to be running into some mega problems here with room, but let's see if I can fit this in. So 1/3 times u would be just u over 3. 1/3 times the 1/2 would be negative, I'm going to write that as sine of 2u over 6, and then plus our capital C. So all we have to do is go in there, make our substitution. I'm going to come down here to my next page and kind of make that substitution in there, where u is specifically the x to the 3/2 minus 1 over 3 minus sine 2 times that, so 2x to the 3/2 minus 2 over 6, and then plus c. So everything right down here, that's my final answer for the problem. And again, this was all doable just by remembering some of our trig substitutions. Now, if you guys need a little help, I'm going back and going, what are those again? I'm really great with my sine squared and cosine squared equals 1. What about all the other ones? If you go to, I think, your back flap of your book, and then turn, once you're touching the back flap, turn your page over 1 time, maybe 2 times. Right in there, there's a huge list of all the different trig substitutions that you can do. And so that's what I would do. I think it's 2 pages back from the back flap. That'd be a great help, especially when going through several of these problems. Okay,